All right, 5-3 day 1. We are going to be solving. It's the jump that we're going to make here. It's one of those lessons where I've got a bunch of examples to do because I want you to see like every possible type that you could see, because each one kind of has little differences to talk over. But we'll just dive right in. Okay, I think there's 12 examples total. This lesson is split up 6 and 6. Okay, first thing you want to do if you're solving is you want to get everything kind of organized on one side. Okay, so here I would add sine squared, excuse me, sine of x, not sine squared. To both sides and getting that, and then I would subtract square root 2 and then divide by 2 and get that. Okay, that is what you're trying to get to. Okay, so you just have a simple statement of like a trig function equaling, you know, whatever it is you have on the other side, just a number, all right? Because then what happens is we get to our solution using the good old inverse trig function, okay? Now you are going to see on these examples, to simplify it, I think in day 2 I'll do 1 in radians. I'm going to stick to degrees, okay, just to keep this as simple as possible. All right, if you remember once upon a time in chapter 4 we talked about inverses, okay, and we were really particular that we took a specific answer with an inverse, okay? And this is now why. We kind of have like two, if you really think about it, when you look at the unit circle, you would notice that this is going to have two solutions. Now, not every solution is going to be something that you can get from the unit circle, okay? But we have to find a method to get both of these solutions, okay? Now, if you wanted to talk radians, you could do this. Okay, 180 is the same as pi. I'm going to be using the 180. So, here's what would happen. You would go to the calculator, and if you did inverse sine of negative square root 2 over 2, you would get negative 45 degrees. Okay, it's that situation where it comes from quadrant 4. All right? Now, there is another possible solution, and that rule that we mentioned right there is what will allow you to get it. If you do 180 minus your first, I shouldn't say your first, the answer that you would get from the calculator, like the one answer we'd get for the inverse, you would get, in this case, 225, and that would be an answer that you're looking for. Okay? Now here I could add, I'm not going to leave my answer as negative 45 degrees, so I can always add 360 because that's the period for this trig function. If I do that, I would get 315, and there's my two answers. Okay? Now you can double check this by checking the unit circle, and you might be like, why wouldn't you just observe those two answers in the unit circle? You could, and you should. I mean, if that's the way you want to do it. What I'm trying to get you ready for with this inverse is how to use the calculator for problems that aren't on the unit circle, which is going to come up a little bit. Okay, now this didn't specify an interval, so I do have to say, with the coterminal thing, this is basically saying list off all the solutions. So for both of these, I have to say, you can add or subtract 360. All right, stick any whole number you want in for n, and then add or subtract 360 as many times as you want. okay? And you'll get all the different possible solutions that you could get. All right, here's example 2. It's a tangent, okay? And now, before I even get into it, I'm going to kind of talk about our little inverse tangent profile, okay? Answer number 2, you'll get this a little bit differently. You don't subtract your first answer from 180, you add 180, okay? You can always verify these patterns on the unit circle and just kind of see with a few examples that they're true. Like in the case of sine, if you find any two angles in the unit circle that add up to 180, you'll see their sine values are the same. That's what's going on with that property. If you look at tangent, find an angle, look at its tangent value, add 180 degrees, and you're going to get another angle that has the same tangent value. All right? Still setting up this scenario where I want a trig function on one side and everything else on the other. So I do the first 2 steps that I added, 1 divided by 3. And now I do the square root. And this actually gives me 2 different cases that I have to think about. Plus or minus 1/3. Okay, plus or minus 1/3. Excuse me, square root of 1/3. Okay, and now this becomes time to do inverse tangent. Okay, so I'm going to look at the case where I would do inverse tangent of the square root of 1/3, all right, and you would get 30 degrees. Okay, it's another one that you could, if you had tangent values on your unit circle, that you could simply observe. This just asked for general solutions and didn't specify an interval, so I have to also say you could go ahead and add 180 as many times as you want. Okay, and you're going to get other solutions. Now over here, I got to account for the case where I could do negative square root of 1/3. Okay, if you did that on a calculator, again, make sure you're in degree mode, you would get negative 30 degrees. Okay, negative 30 degrees. That's not, the answer. It's a solution, don't get me wrong, that's fine. Go back to your rule. Immediately add 180, which we can do with tangent. Okay, now notice I need this solution because if you look to my first, I can add or subtract 180 as much as I want to get more solutions. But if I were to do that, I'm not going to hit 150. I could add 180 to 30 and I would go right to 210. Okay, which is why we got to have this second solution. All right. From there, I can add any multiple of 180 and I'll get more solutions. Okay. That's why that rule is so important. And when we go back to when we first saw the inverse, the reason we get that negative 30 degrees, that's why the calculator gives it to us, is if we use this rule, it works out to get both possible sets of solutions. All right, here's one that we'll need a little bit of factoring. Okay, this one looks a little bit different from the others because it's got 2 different trig functions, which in general, that typically does make the problem a little bit more complicated. Okay, typically does. So on this one, I've gotten everything on one side, and I notice this is another good way to handle these is get it all on one side and check and see if you can factor. Because that's one way to handle the two different trig functions. And you'll see another example later where we handle it with doing a substitution with an identity. If we can split them up into factors like this, I could solve that, and then I could solve that. Okay? Cotangent equaling 0. We don't do a ton of solving with the reciprocals. You'll see another one in day 2 where we deal with them a little bit. Typically, if you get one that's got a reciprocal, it's going to be on the unit circle. And so you would notice, if I'm talking degrees, the only place on the unit circle where cotangent, I shouldn't say the only place. The first place is at 90 degrees, and then just like tangent, it has a period of 180. So I could start at 90 and then do any multiple of 180. Okay. Now, we haven't talked a lot here about cosine, right? We got that kind of, with sine, you do 180 minus your first answer. With tangent, do 180 plus. But we really haven't gotten into cosine, and we're actually not going to here. It kind of seems like we are. But you could go to your calculator there, and the square root of 2 is like 1.4. So this isn't the time to talk about cosine yet, because you're not going to get any solutions. Okay, it's, 1.4 or negative 1.4, it's not possible to have that as a cosine value, so that's kind of the end of the road for the other factor, is we just don't have any solutions. All right, here's one that kind of looks a little bit like a quadratic. Okay, we still aren't going to address the cosine situation because this is sine, and we've already talked through sine, but we haven't seen one that has this quadratic setup. Now notice here in the instructions, I'm going to switch this, right? I don't want every possible solution. Like the first 3 did that, and it's like, hey, there's an infinite number of solutions. Kind of give me the ones I need to get started, and then, add or subtract 360 or 180 to get the others. This problem isn't like that. It's saying all we want are the solutions that you can get from 0 to 360. Beyond that, we don't want them. Different problems could specify different intervals. Okay? If you do have a trig function that takes on a quadratic form, factor it. And then what you have here from your first factor, if I set it equal to 0, I get that, and then this one here would be 1. Okay? You split it up into 2 smaller ones that are a little bit easier to use. Okay? So now I'm at the point, right, that's what's going on here, is it's time to do an inverse. So really the question that I would ask here is, what's the inverse sine of 1? Okay? Here's a unique case where I'll only get one answer, right? The calculator will tell me 90 degrees if I do inverse. Now, this whole second case, you'll see a few circumstances where we're kind of ready for it because it could yield more solutions. We're not guaranteed it will. Like, look right here. With sine, you do 180 minus your first answer, and wait a minute, that's just going to give us 90 again. 90 is the only solution. We should always check the second possible case, though. Okay? For example, okay, if you were to do inverse sine of negative 1/2, the calculator is going to give you negative 30 degrees. Notice that's not in our interval, and it's not a solution that we want. Okay? However, if I want to use our little rule to get a second possible, like the second possible set of solutions, that's the number that I have to use. Okay, that's why the calculator gives it to us, is it works with the rule for inverse sine, because then notice we get 210 degrees, and that's a different solution that we haven't seen before, and it's between 0 and 360. Okay, so it's one that we want. So what do we do up here? Okay, don't forget that you can always apply the concept of a coterminal angle, right? Add or subtract 360 as much as you want. If we add it once, we get 330. So this one will have 3 solutions, 90, 210, and 330. All right, this one is going to be basically another quadratic, except it's got this complicating factor of it's got 2 different trig functions. Okay, it's a bit of an issue. Now, I showed you one where we had 2 different trig functions and factoring was the thing to do. You could try that here. It's not going to work. The other scenario that you should be ready for is perhaps we need an identity. Sine squared works pretty well with the Pythagorean identity. And I can make that substitution, right? Right there. Sine squared out, 1 minus cosine squared in. Okay? Distribute the 2. And obviously what I like about this is now the equation that I'm working with is all in terms of cosine. See, the last term here would become minus 1 after we add 2. We would have negative 2 cosine squared plus 3. I'm not really thrilled with the negative sign out front, which I can, when I'm solving, I could switch it so long as I switch the middle and then switch the last. Okay? So you might, some of these are progressing here a little bit in their difficulty. We now this basically gets to the point where it looks like the one we just did in terms of being a quadratic. The added element here is we had 2 different trig functions to begin with, and we had to use an identity to get it all in terms of cosine. Okay? From this point on, this should look really, really similar, okay, to the one we just did. All right, setting these equal to 0 with the first factor here. We would have cosine of x is a half, and then cosine of x equals 1. Okay? And now we get to an interesting point about using the inverse. This is kind of our final case that we have to see. We haven't addressed cosine yet. Okay? It has, for getting your second set of solutions, a different rule altogether that you have to take if you're talking degrees. 360 minus your first, if you want to talk in radians. You got to do 2 pi. You notice I'm still sticking with degrees. I think you'll see one example in day 2 where I'll switch and use radians. Okay? So this is another one by looking at the unit circle. You can see a few examples to convince yourself that it's the case. Find any two angles on the unit circle that add up to 360. Any two. You will see they have the cosine value, the same cosine value. It always happens. Okay? So now, as I do inverse cosine of a half, okay, you're going to get 60 degrees. Now this didn't ask for just 0 to 360. This had wanted all the solutions, so add any multiple of 360. Right? Take that first answer away from 360, and there you will get your second set. Okay, and notice there, that's important to get that second set of solutions, because if you go off the first with 60 degrees and you add 360, you will jump over the solution of 300. You won't hit it. You'll go right up to 420 as your next possible solution. Okay? Inverse cosine of 1 is 0. I'm solving the other factor now, and then you would have to add 360 or any multiple. Okay? You could apply the rule, right? So this is a case where if I went and did that, it'd be like, okay, I got to do 360 minus my first solution, which was 0. Well, that gives me 360, which I have covered in my first solution, right? If I add 360 once, I'll get to it. So we always check the second case, but for this factor, it didn't give us any new solutions. All right, last one here, the first day, example 6. Okay, a little trick on this one. It's fairly tough. Little something you can try if you get stuck. Like my first instinct would be subtract sine on both sides, but it doesn't work well. If you do get stuck on one like that, try squaring both sides, okay? And the reason I do that is, like if I just subtracted sine of x, I would see it's not factorable, which means if I can't factor, I need to use a trig identity to substitute. That's like my only option to get one single trig function. Well, as it was originally written, I didn't have many options. Now I do, okay? I've got sine squared over on the right side. I could use a Pythagorean identity, and there you go. Look at that. We're all in terms of cosine, okay? So a little trick that doesn't come up a lot, but if you have two different trig functions and you're like, identities don't work, it's not factorable, that would be the next thing to go to. Okay, square both sides. And this actually simplifies pretty well. If I add cosine squared to both sides, I now have 2 of those. And then the 1's actually cancel as I subtract 1 from both sides. These each have, whoops, I forgot my 2. These each have a factor of 2 cosine of x, which would leave 1 factor of cosine of x from the first term and just 1 from the second. Divide both sides by 2 here, and again what I'm after when I'm factoring is to get to this point right here, where I've got 2 trig functions exactly where I want them. Okay, ready to take an inverse. The first one, which, I mean, a lot of these have been on the unit circle, but I really don't mind if you get in the habit of using your calculator, because in the second day, you're going to see ones where you have to, and I would prefer that you, that you know what you're doing with the calculator. So when you do the inverse here, and I can't remember, did this ask, whoops, I should have mentioned this at the beginning, right? Want solutions from 0 to 2 pi degrees, right? We just want to stick to degrees for our first day here. All right, so you do the inverse, right? You type an inverse cosine of 0, the calculator is going to tell you 90 degrees, okay? And to get our second solution, with cosine, we take that one and subtract it from 360, and we would get the solution of 270, okay? So that's a case where it does yield another solution, 90 degrees and the 270. Now check this one out for the other factor. If you were to do inverse cosine of -1, you would get 180 degrees, okay? We've seen this once before today. If you apply the rule, it a lot of times generates new solutions that you need to find. Sometimes it doesn't. 360 minus our first answer, that gave us the same answer again. Well, okay, that's fine. We checked. From that factor, 180 is our only solution.